All right, guys, let's keep it pretty simple. So we're looking at creating or really understanding how horizontal compression and stretching works. So I'm just going to use a very simple graph. This is just the most simple parabola, which is your parent function quadratic or a parabola. And then I'm going to create a slider. Let's put any letter that's not my defined variable. So here I'm telling it that the variable is x, but if I put a c in, it'll ask me to add a slider. Let's do it. Now let's watch what happens when c gets bigger. This is actually a vertical stretching compression. To make it horizontal, I need to put it inside the parentheses. So you can see how that's completely different. Just for contrast. Let me do, well, see how they're both changing? That is cool. So you can see, well, it might not be intuitive to you. So let me show you if we add, what if we add, I'm going to add, I'm going to make it simple again. But I'm actually going to make this equation a little bit longer. I'm going to say 3x, let's say plus 2. Okay. And then what I'm going to do is I'm going to take an equation and just say g of x is equal to, and then we're going to say f, and we're going to put the constant inside. And what this does is this allows us to see what happens when we change. You'll notice the y-intercept is fixed. And I can show you why that is. But as we change this, you can see as our constant value gets bigger, our graph is actually getting more narrow. You can see it's getting skinnier. And how I think of this as, is just getting to the y values much, much faster. So all the way at 10, it's getting there 10 times faster. So if you look right here, that's the intercept. This value at what? Over 1 up 6. This is probably going to be 1/10. That's very close to 1/10. And just, it's me being not good enough to slide a tiny fraction with the mouse. There we go, 1/10 and 6. See how that's happening 10 times faster. So when your constant is bigger than 1, it's going to get more narrow. When it's less than 1, it's going to get wider. So let's write some of this down real quick. All right. So for vertical compression, or vertical stretch, remember, this should be horizontal. So for horizontal stretch, remember anytime it's side to side, we're talking inside, up and down is outside. So we're going to have two different situations. Remember this C is a constant. It just means a number. I think of that as a hashtag. That also means number. It's just a number. So we have two different situations. If C is bigger than 1, it's going to compress. If C is a fraction, sorry, I don't want the equals to, it's going to stretch it. And let's just take it a very simple equation and walk us through why this happens. So why is this happening? So if we look at f of x is equal to keeping the number small, we're going to do a very small table here. X, f of x, and then let's look at f of 2x. So let's look at the numbers 0, 1, 2, 4. Let's look at really simple numbers. So if I plug in 0, f of 0, well, that's easy. 0 squared plus 2 times 0. Please don't write 20. 2 times 0. I just have 3. That's simple enough. Now let's look at it if it's 2 times that. So we're doubling the x value. This is saying double x. So we're saying f of 2 times 0. Well, what's 2 times 0? That's really just the same thing as f of 0, which we already know is 3. So that didn't change at all. But let's look at a more interesting one. F of 1, 1 squared plus 2 times 1 plus 3. F of 1 equals 1 plus 2 plus 3. That's 6. Now 2 times that's going to be f of 2 times 1. Well, what's 2 times 1? Just 2. So we're going to have 2 squared plus 2 times 2 plus 3. Well, 2 squared is 4. 2 times 2 is 4 plus 3. I'm getting 8 plus 3, which is 11. Notice the 6 didn't double. We're changing the input. So this is changing our input. Let's take a look at 2. Well, we just did 2, basically, didn't we? That was the exact same thing, so that's 11. Notice that this is taking the output from double your x. So double the 0, that's going to be the same. But if I double 1, I'm now looking at the output from 2. So what we're looking for is I'm betting that these two squares will have the same thing. These two squares have the same thing. Now the reason these two don't is because 0 times 2 isn't 1. This isn't addition, we're looking at multiplication on the inside. So let's finish this up and see what we get. We already know that f of 2 is, let me erase that. No, I said eraser, please. So let's take a look at 4. We're going to have 4 squared plus 2 times 4 plus 3. 4 squared is 16. 2 times 4 is 8. And that's 3. 16 plus 8. 24 plus 3, 27. And if I have f of 2 times 2, well, that's the same thing as f of 4. That's exactly the same thing. And then if we look at f of 2 times 4, that's the same thing as f of 8. So we don't have f of 8, so we'll have to find that real quick. Eight squared is 64, plus 16, plus 3, 70, 80. I get 83? Yep, 83. Now, I think it's a little bit easier to look at it with a graph. So let's look at it with a graph. I'm actually going to go to the first example that I have for you guys. So we're going to take these points right here. These points are key. So I'm going to go, and we have over 1 up 0. And right here we have over 9 up 1. Now this, they're asking us to sketch, but on yours you're going to have multiple choice, so it's pretty simple. But let's take these and let's think about it. So we're looking at x, y, and then f of 1/3 x. So we're going to have to think about what this means. So we got 1, 0, and we've got 9, 1. So let's take a look at what this means. So if we say we can only use x's we know, so we can only put in 1 and 9. So I need to figure out where 1/3 is equal to 1 and where 1/3 is equal to 9. So I'm just going to multiply by 3. So x of 3, there's not really room for me to write there, so I'm going to times by 3, times by 3. So these are the ones that I want for my, I'm going to be using 3, and I'm going to be using 27. Well, when I plug in f of 1/3 times 3, which is really my g of 3, g of 3 is the same thing as f of 1. So this is my g, and that's just a 1. Oh, sorry, that's not 1. This is like when I have 1, I'm at 0. And if I do the same thing, so g of 27 is equal to f of 9. Now what that really means is this 0 right here is going to move all the way over to 3. And this 1 right here, this y value of 1, is going to move all the way over to 27, so something over there. The asymptote's not changing, so it's still going to be going vertical right here. It's going to take a heck of a lot longer to get there. So what we're looking at is we're looking at a stretch. We're looking at it's taking 3 times longer to get there. Instead of getting to 0 at 1, it's taking all the way till 3. Instead of getting to 1 at 9, it's taking 3 times longer. So instead of 9 minutes, it's now taking 27 minutes. Instead of 9 seconds, it's 27 seconds. Whatever our units are, it's taking 3 times longer. So for me, I'm going to go back to the very top. On this, I would add, for me, I would think of this, let me just, I'm going to erase that. I would think of it as when C, oh, I've got to click on the right, when C is a fraction. Now it's important that you pay attention to the fraction is less than 1, because 5/4 is a fraction, but it's bigger than 1. When C is a fraction less than 1, it takes longer to get there. When C is bigger than 1, it gets there faster. So for this one, you're thinking, think fat. It's going to go like a fat graph. And this one's going to be skinny. It may seem silly, but honestly, when I was thinking of this, when I was doing this when I was in high school, I honestly thought of if it's a fraction and it's taking a long time to get there, I would be like, okay, This is me on my fat days when I don't want to work out and I only do a fraction of the workout. If I'm only doing part of the workout and not getting there. And this one is when I'm going more than 100%, more than what's expected. Those days, I'm feeling strong. Those days, I'm fast. Those days, I got some muscles. Okay, those are my very great muscles. But that's how I honestly remembered this. So let's do some examples. Let me put that on another video so this isn't super long.